Okay, so I want you, if you haven't already done so, go to page 10 in your packets. I want you to follow along in your notes just like you would in class. Now I have some of this filled out already, so we're just going to kind of go through it together. So I want you to go to page 10, and we're going to start off by doing the top problem, which is substitution. This is what the video was over on Friday, but based on my views, a lot of you did not take the time to watch the video in class. So that's why we're hopefully watching it all together and forcing you to watch. But I'm going to go over an example of substitution, so hopefully it makes a little bit more sense. Okay, so if you remember from when we started this lesson before I left, solving a system, there's three ways. You can solve by graphing, which is like what question number 2 is about, meaning you're going to graph the two equations and you're going to see where they cross. And then there's 2 additional methods, substitution being one of them. The goal of substitution is still to find the point where they intersect. We're just doing that without having to take the time to graph it. So to use this method, step 1 is you want one of your equations in the form y equals mx plus b. And if I look, my top equation is in that form, so I'm good to go there. Then you're going to take that information for y equals mx plus b, and you're going to substitute it in for y into the other equation. And what I mean by other equation is the one that's not in the form y equals mx plus b. So I'm going to rewrite that equation out, the one on the bottom, and when I get to y, I'm going to substitute in 7x plus 15 because it tells me that's what y equals. And whenever you substitute it in, you should always put it in parentheses. So as you see here, I wrote out my bottom equation as negative 2x plus 2, but once I got to y, I put parentheses and I wrote in 7x plus 15, and then I finished out the equation with equals 18. That's the hardest part of substitution. Once you get it rewritten, that equation that wasn't in the form, y equals mx plus b, once you get it rewritten, from there you're just solving for your variable. So I solved this equation for x. I started by distributing, and that's how I got the 14x plus 30. I put negative 2x and positive 14x together, and I got 12x. So I now have 12x plus 30 equals 18. I subtracted 30 from both sides, and then I went up here. After I subtract 30 from both sides, that leaves me with 12x equals negative 12. Divide both sides by 12, and you get x equals negative 1. So that's half your answer, because again, you want the answer to be a point of intersection where they would cross. So over here where I started to write my answer, I wrote negative 1 in for x because every point is in the form x comma y. I wrote negative 1 in for x because I had half my answer. So now to get my y value, I go back to one of the original equations, it doesn't matter which one, and you're going to plug in negative 1 for x to see what you get out of it for y. I chose the top equation, and this is where I rewrote it over here to the right, because the top equation looked easier in my opinion. So I wrote it as 7, but instead of times x, I substituted negative 1 and then plus 15. 7 times negative 1 is negative 7. Negative 7 plus 15 is 8. So my y value is 8. So the point where they cross, and my answer is negative 1 comma 8. So hopefully that helps you in terms, at least a little bit, in terms of substitution. So you can at least attempt the homework. But what we're going to do now, I want you to go over to page 11, which I started writing out as well. So on page 11, you can cross out the warm-up because since I'm teaching you on a video, we're just going to go over what's necessary. And on page 11, we're going to jump down to elimination. So this is the last method of our 3 that we can use to figure out the point of intersection. So the elimination method is also known as the addition method because you're going to add the 2 equations together. And the goal of adding your 2 equations together is that one of your variables end up canceling out. You want one of your variables to cancel out. If they don't cancel out, then I'm going to show you what you're going to do on the next page. But in this case, something does end up canceling out. And what I mean by that is if I start adding these two together, I'm going to start off with 5x plus 3x, because those are like terms, which gave me 8x. And then I had negative 6y plus positive 6y, and that equals 0. A negative 6 plus a positive 6 is 0. It cancels out, the y is gone, which is, again, one of my goals for solving with elimination is to get rid of one of the variables. And then negative 32 plus 48 gives me a positive 16. So this is what I'm left with after I add the two equations together. Then, just like with substitution, once I substitute it in, so in this case for elimination, once I add them together, I'm just going to solve for that variable. So I'm going to divide 8 on both sides, and that gives me x equals 2. So that means I have half my answer, because again, the point is going to be where your two lines intersect. So now what I'm going to do, to find my y value, I'm going to go back. This is exactly how we finished off substitution. I'm going to go back to one of those two original equations, and I'm going to plug 2 in for the x. It doesn't matter which one. I'm going to choose the top one. So it's going to become 5 times 2, because x is 2, minus 6y equals negative 32. Okay, so here's what I have. I substitute in 2 for the top equation for x. I'm going to solve it. So 5 times 2 gives me 10. And then I still have negative 6y equals negative 32. Subtract 10 on both sides. That gives me negative 6y equals negative 42. Then divide both sides by negative 6. And you get y equals positive 7. So, that is the point where they intersect, 2, 7. So there's my answer for the first one using the method elimination. Okay, so let's go on to the one right beside it. So solving with elimination, it only works if I can add them together and one of my variables ends up canceling out. So if I look at this system, I notice my x's are going to cancel out because negative 3 plus a positive 3 gives me 0. The x's are now gone. So in this first example, the y's canceled out. In my second example, the x is canceled out. Doesn't matter which one, as long as one of them is eliminated. So then negative 3 plus negative 4y gives me negative 7y. And then 9 plus 5 gives me 14. So there is what I'm left with when the x's cancel out. So I'm going to finish solving. In this case, all I got to do is divide both sides by negative 7, and I get y equals negative 2. So I have half my answer for my point of intersection. I know the y value is negative 2. So now I'm going to go back to one of the original equations and plug in negative 2 for y this time. So, I don't know which one. Let's choose the top one, or let's do the bottom one this time since we did the top one over here. Okay, so it's going to become 3x minus 4, but instead of y, I'm going to substitute in negative 2 equals 5. So now I'm going to solve this equation for x. So I'm going to bring down the 3x. Negative 4 times negative 2 is positive 8 equals 5. Subtract 8 on both sides. I get 3x equals negative 3. Divide both sides by 3, and x equals negative 1. So there is my answer. The point where these two lines cross is at the point negative 1, negative 2. Okay, so hopefully this is kind of connecting for you guys. I know it's not the same as if I was there teaching it at the board, but hopefully this helps a little bit. All right, so let's go over to page 12. And let's do one more example. So it's still solving using elimination. And again, the goal is you should be able to add them together and one of your variables ends up canceling out. Well, in this case, -2 plus 7, the x's won't end up canceling out. And then if I check my y's, 15 plus a -5 also does not give me 0. So the y's don't cancel out either. So this can happen, and this is going to happen on your homework and a few problems and on your test. So what happens if it says you want to solve by elimination, but none of the variables are canceling out? You're going to manipulate, I guess, if you want to call it that, one equation or sometimes both, just depends. You're going to kind of manipulate them, change them so that one of the variables does end up canceling out. So you could choose the x's to try to rework so that it cancels out, or you can choose the y's. I'm going to choose the y's, and I'll tell you why. So I want this 5 to become a 15, because if this 5 is a -15 and a +15, the y's will cancel out. So what can I multiply the 5 by so that it becomes a 15? Well, I can multiply it by 3. So if I'm going to multiply this 5 by 3, I have to do the entire equation. So I'm going to start off by multiplying the entire bottom equation by 3 so that these y's end up canceling out. I chose the y's because that was easier. If I look at the x's, 2 times nothing will give me 7. So I would have to end up multiplying both equations by a number, and that's just more work. So that's why I chose the y's, because I knew 5 times 3 would give me 15, and the y's would end up being the same number, and they could cancel out. So I'm just going to bring down my top equation, the -2x plus 15y equals -32, because that's not going to change. And I'm going to distribute a 3 in for all the numbers in my bottom equation. So 3 times 7x is 21x. 3 times -5 is -15y. And 3 times 7 is 51. Okay, so from here, I can add the two equations together, and now a +15 plus a -15, the y's will end up canceling out, which is what I want. So what I want you to do right now, I'm going to give you a couple seconds. Hopefully you're working along with me. I want you to try to finish this. So add your x's together, add your constants together, and you'll end up solving for x and see what you get. So go ahead and do that now. Okay, so you should have got -2 plus 21, which is 19x, equals -32 plus 51 gives you 19. Divide both sides by 19, and you should have got x equals 1. So hopefully you got that. So you have half your answer. So they intersect at a point, and I know my x value in that point is +1. So now you're going to go back and plug 1 in for x to solve for y. In this case, you have a few equations you can choose. You can choose to plug 1 in for one of the two original equations, or you can even plug it into the equation that we got after we multiplied everything by 3. Doesn't matter, you're going to get the same answer. I'm going to plug it in for the top one. So I'm going to replace the x with a +1. So it's going to become -2 times 1 plus 15y equals -32. -2 times 1 is -2. Add 2 on both sides. 15y equals -32 plus 2 is -30. Divide by 15, and y equals -2. Again, I know I did that last part kind of fast, but I'm hoping we know how to solve an equation by now at this point in the year. So my answer is the point where they cross, which is 1, -2. So we're going to stop there because I don't want the video to be super long. This is all the methods. So this is what your test is going to be over, which is not until the 9th. So I'll be back in time to review with you guys. But it's going to be over graphing, substitution, elimination. Hopefully this helped a little bit and you can work on the homework. You can do all sections now, at least attempt them, start it, whatever, until I get back. And in the meantime, you can always email me with questions, okay? So please work on the homework and let me know if you need help, just by emailing me or again when I get back.